What's up guys, Shawnthebro here, and we're back for another episode of cleaning up our fighting game tutorial series so that we can prepare for rollback netcode online and some deep dives into things like AI and story mode as well. And in the previous few episodes we have been taking care of the hitboxes and the animation blueprint and the game mode, and we're going to continue along this track today of just cleaning things up so that we have a nice to use product. Should be clean so that we can easily expand upon it. One thing I want to go back and clean up now with some of the progress that we made in the other cleanup episodes is our character blueprint. We started with the character and then we started running into some things with the game mode and the animation blueprint I wanted to handle before finishing that. And now that we've cleaned up some of that stuff that is related to the character blueprint, we can go back to the character and continue to tackle this some more. If you want to get caught up in the entire fighting game tutorial series, and you can see how we've done things from our hitboxes, our throws, our special attacks, and a lot more, I'll link you to the entire playlist right here in the top right corner. Alternatively, if you're just interested in cleaning up your character class or cleaning up your code in general within Unreal Engine, C++, and Blueprints, I still recommend you watch the other episodes where we cleaned up some of the character files within our game, because you'll see what we started with, how we had the logic set up, and how we improved it in those episodes, so you get more of an idea of why we're doing the things that we're doing, cleaning them up, making them more efficient. So I'll link the first episode of the character cleanup right here in the top right corner. Now this is a code and blueprint tutorial series, and we're going to focus on cleaning up our character today, but mainly I want to clean up my character blueprint. Some of it can be converted to code, some of it is just old logic that we don't need anymore. So let's go into it. Let's start in our blueprints, character BPs, base character BP. This is our parent character blueprint. And we have a lot of logic in here. Our character is quite complex, nothing wrong with that. So before we even get into any logic, just note that I made a change in the 3D conversion episodes that is very important here. We don't really need it because the way we set it up, we were working around it, but just note that my arrow now faces the same way my character is facing. Technically, the character was rotated 90 degrees. So the arrow was facing this way and my character was facing to the right. And we had to make that change to align our hitboxes and movement properly in the 3D conversion. It's not something you have to do for the 2 and 2.5D fighter, but just be aware that that change was made, whereas in those episodes I typically try to avoid changing any of our main logic. But that's something that didn't really have an effect on our 2 and 2.5D logic, and it could be changed without too much trouble. Now going back to the base character blueprint, if we go to the event graph, we can start looking through our logic here. If we scroll down to below where we have our keyboard mode inputs, you'll get to a section where we have on component hit with our capsule component. And this is where we're doing our pushing logic for our characters. It was being done in Blueprint, and that's perfectly fine, but our capsule component is our root component. There's our capsule collider for our character, this little pill shape here. And it is accessible within the code, so we can easily come in here, convert this logic to code, which will make it more efficient and easier to upgrade it in the future. So today's episode is mainly going to be about improving this by converting it to code, but there will be a few other things that we edit as well. First things first, if we're going to do this, we need to know that we have an on-component hit binding, and we're going to check the character states for certain states, and only if they're in those certain states can we push the character. So if the collision occurs and the other actor is another type of character, and we're in one of the appropriate states, we check to see if the other character is not moving, because that's the only state we can push another character in while they're in it. And if they are, we determine the direction they're facing and add an offset based off of that. So to convert this, the main part that we need to do is make sure that we can bind this collision right here, this on component hit with our capsule component. If we go into the code, we can go to fighter_template_character.h, and we can make a binding function, or a function to receive on component hit. So in fighter_template_character.h, we can go down to our functions in the class, and we'll keep it a public function. We can put it above where we start making our blueprint callable functions. We can call this whatever we want. On the blueprint it's called on component hit, but we can call it on collision hit or on capsule collider hit, whatever we want. I think this one is pretty good. And for the comment, collision has occurred with the capsule component. And I'll change this from capsule collider to on capsule component hit, just so we know exactly what we're dealing with. Even though that is our capsule collider, when we look at it in Unreal, it is called a capsule component. Now we have to fill it out with all the information that collisions pass along in Unreal so that we can actually bind it to a collision when Unreal detects that one occurs. And that basically means we need to capture all of these variables that are here. Our first one is going to be our hit component. Then we have our other actor, our other component, our normal impulse, and our hit. First one is U primitive component pointer, and I'm going to call it hit component. Then we have another A actor pointer for other actor. And I'm capitalizing these like they are in the blueprint, but I call these hit component and other actor camel case like that. And then we have U primitive component pointer again, and this one is going to be other component, F vector, normal impulse, and hit. I believe it is a const hit result reference structure called hit. And F hit result, excuse me. Make sure we know it's a structure. Additionally, I like to have my parameters with an underscore in the front. You don't have to do this, but just so I'm staying consistent with the rest of my logic here. If I didn't write the function and it is an Unreal function, you'll see the parameters are typically capital with no underscore, but I do like this method, so I'm going to stick with that for now. And now we have our function that we're going to bind. We need to make this a U function so that it is safe. If we don't, we will often crash when playing our game when we collide and meet this condition, because we are going to be binding to an event that Unreal has, and if we don't make a U function, it won't work. So we don't have to put anything in here, but make sure that it is U function parentheses. Now we can go back to fighter template character CPP and go into the constructor. You can pretty much do this wherever you want. I tend to put it down at the bottom, so bind collisions to functions. And we want to bind our component, so we have get capsule component. This is our root component as well, so we could also get root component, but if we get capsule component, we already know it is of the right type, and we're going to bind this collision on component hit, and we're going to type dot add dynamic, and the object that we're binding is this object or the character, and we need to determine the function that we're going to call. So we need to do ampersand and a fighter template character colon, and we're going to call our new function, which is on capsule component hit. So now we can go to where we want to create this function, this on capsule component hit. I'll scroll down to below the landed function where we made it in the header file. Void a fighter template character colon on capsule component hit. And in the parameter list, we need our parameters. So it's U primitive component pointer hit component, A actor pointer, other actor, U primitive component pointer, other component, F vector, normal impulse, and const hit result, F hit result, reference or ampersand underscore hit. And since this is quite a long function, we can enter it down if we want so that we can see it on the screen pretty easily. You don't have to do it, it is up to you, but you can do this with any function. Like if I go down to the one below it, it just stops the line from going so far across the screen, because if you have to scroll, it could be annoying. You might want to see it in one spot. I went over this in some of my other character cleanup episodes, so it's entirely up to you. If you don't want to do it, no worries. If you do, you have the ability to. Then in here, we just want to do whatever logic it is that we had bound in Unreal. So now we have all of these parameters, and this is going to be getting called. So I'm taking my other actor and casting it to the specific character type. That makes sure that we're even colliding with a specific character first, because if we're just colliding with something like a wall, we don't want to try and push it. And we also have to make sure that we're in the correct state. if character state equal. The states that we have are moving forward, moving backward, dashing backward, or running forward, running backward. E character state, E underscore moving forward, or character state equal E character state, E underscore moving backward. I'm going to enter and do or just to keep it clean. So character state equal E character state, E underscore dashing forward. Or I didn't finish this one. E character state, there we go. And we can just copy this if we want to make our lives easier. We don't have to type it out every time, but make sure we change this one to E dashing backward. Enter, or, and we're going to paste this again, and we're going to check for running forward or running backward. So now we've checked for all of our states. If our character is one of those states, we can push another character. So the next thing we want to check is if other actor. And we need to cast this to a specific type or check if it is of a specific type. So to do this, we can cast a fighter template character, and we're casting other actor. So if other actor is of the fighter template character type, then we can set it equal to a fighter template character pointer other character equals. So if this succeeds, other character will not be null pointer, which means it will be valid, and we will go into this if statement. So we've covered this and all of this. So everything in here is covered. Now we need to check if the other character's state is no action or they're not moving. So if other character state, and I believe we have a getter for this. We do not, so you could access it if it is public, just through character state like this. If other character state equal E character state, E underscore not idle, or default is what it's called in this case. Basically idle or not moving. This means we are able to push them. So we just have to determine which direction we want to push them. So the way we do it now, and I will continue to do this, is by checking to see if they're facing right or not. However, we may want to push them just based on the direction that we're moving for various reasons, one of which being the 3D movement, so this may be subject to a little bit of change, just taking in the direction we're moving and not the direction the character is facing. But for now, we are determining the direction that we are facing, so if is facing right. If we are, we're going to add one offset. If we're not, we're going to add another offset. So we'll have that else in here. And specifically, we're going to call add actor world offset on the other character. And we're passing in a default of 0.8 on the Y or negative 0.8 on the Y. So if we're facing right, then other character, add actor world offset. For the parameters, it takes in an F vector. And that is the vector I was showing you just earlier. So the X is 0, the Y is 0.8, the Z is 0.0. If it's false, or the else statement, it's going to be 0, negative 0.8, and 0.0. So F vector is 0.f, 0.8f, and 0.0f. Then after the F vector, we check for the sweep and the teleport. So sweep means we're going to check and see if we're colliding with something else. If we are, we won't add the movement. If we're not, we will add the movement. This is so they don't get pushed through objects, such as the stage boundaries. So we definitely want to enable this. Teleport is more for physics. If we're enabling the physics and we teleport, are the physics changed based on that, or do they remain the same? We don't need that. So if we go back into the code here, we want to pass in true for sweep and false for teleport. And we can copy this line and paste it in the else, but we have to make sure to change the Y to negative 0.8f. And we could make this a variable to clean it up, but otherwise that is the logic that we need. So at this point, I recommend disconnecting your logic and deleting the onComponent hit in here to be able to test it. You could delete all the logic, but you might want to wait just to make sure that the code logic actually works for it. It is up to you. But I'll compile and save, because worst case that happens here is this doesn't work and we could add the event back, but it will work. So at this point, go ahead and close. So to make a variable, we can go to the header file, fighter template character.h, and scroll down to where we want to make this variable. And I'll put it here at the bottom of my floats, and we'll say the amount of push applied to a character when walking into them. We'll make this a U property so that we can see it in the blueprint and edit it in the blueprint as well. So edit anywhere, blueprint read write with a category of movement, and we'll call it float push amount, or actually let's call it push distance, and we'll change the comment to the amount of push distance applied to a character when walking into them. When we have our variable here, we can go back to the CPP file, go to our initializer list where we set the values for all of our variables. I'll put it in the same area that it was in the header file. I'll put comma, push distance, and in parentheses the amount that we want. We were using 0.8f in the blueprint, so I'm going to continue to use that. And now we can go back down to our function here, where we're colliding with our capsule component, and change the y-axis or y value to use this push distance that we have now, and negative push distance for that else statement. At this point, you can relaunch the project. Everything should work as expected, as it did prior to converting this from blueprint to code. And if it does, you can then go ahead and remove the blueprint logic for the on component hit that we removed earlier. So back in the base character VP, you can remove all this logic that was associated with that event since it is now in the code. Thank you guys so much for watching this episode on how to improve your character in your fighting game series, specifically our push mechanic by converting it from blueprints to code and giving it more scalability. If you enjoyed this episode and learning about how to clean up your code, then please subscribe and consider joining the Patreon, YouTube membership, or Discord subscriptions to benefit the channel like so many kind souls have. I'm very grateful for you. If you ran into any problems following this tutorial or any of my tutorials, feel free to join the Discord community. There is a link in the description. I would be happy to help you out with any problems you ran into along the way. Thank you guys so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.